Here we go.
Yeah.
It's on now. Perfect. Now, what we're going to have a look at is what's called degree 2 systems. And these are basically two linear equations. So here's a simple example of one. Something like x plus y equals 5. And we'll say like x minus y equals 1. And it's our job to figure out the x and the y. Now, I know, you probably know how to do this. But what we're going to learn today is the 3 different ways, at least, of doing this. Okay. Now, you might say, well, why do I need 3 if 1 is good enough? Sometimes in the exam, they will say which method they want you to use. So they might say, solve this by using this method, you know. So you do need to know the 3 methods for the exam. Okay. Now, the first method is by graph method. So this is method 1, the graph method. You know a linear equation represents a line on the graph. Yeah. So if you have 2 linear equations, finding the x and y is the same as finding what's this point called where they meet? Intersection point. Yeah? Intersection point. So let's draw this and find the answer that way. Now, remember we did this already. How many points do you need to draw this? You need 2 points. So you should put x 0. And if x is 0, what's y? 5. Good. And the other way as well, if you put y 0, what's x? 5. And for this line, if you put x 0, what's y? And if you put y 0, what's x? 1. So if I draw this carefully, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The first one is 0, 5. And 5, 0. So there's the first line. Okay. And the second one is 0 minus 1 and 1, 0. Okay. And you can see that this point here, that's not perfect, that is 3. Sorry. And that is 2. So the answer is the point 3, 2. Yeah?
How did you know it was minus 1?
Ah, yeah, so I put x is 0 into this, and I solve for y. And then I put y is 0, and I solve for x. This might have been the lesson you missed. When was your first maths lesson?
Monday. This Monday.
What did we do on Monday? Anyways. Can you write that down? That's the first method, the graph method. So is this a good method or a bad method?
Bad.
Bad. Why?
That's accurate.
It's very bad, actually. Oh, it's not very bad. It's just bad. Did you write that down?
Yes.
Yeah. Marwan, Abdul Rahman, Son, Ming, Jason, Abdul Ali, Kayhan, Jeffrey, Peter, Daniel.
No, Daniel left.
Oh, wait, David.
Yeah.
I made the same mistake earlier. Okay, David. And Dami. Yeah. So Daniel. Wait, no, hang on, I forget. Daniel. No, David.
Yeah,
David.
Yes.
Yeah. Daniel has moved into science.
Yeah, I think so.
Yeah. Okay. Right, you got that?
Yes.
Yeah.
Yeah.
We'll have a look now at the second method. Can I scroll down? Yeah. So the second method is substitution. So in this method, let's take an example. 2x plus 3y, I don't know, equals 5, and x plus y equals 2. So in this method, what you do is you choose one of these and you make y the subject. Which one will be easier to do that for? The first or the second? The second, yeah. The second one you can say y equals 2 minus x. And then what you do is you sub that back in. So now you have 2x plus 3y, which is 2 minus x, equals 5. Yeah? So that is 2x plus 6 minus 3x equals 5. So that is minus x plus 6 equals 5. So that means 6 minus 5 equals x. So x equals 1. And then you sub that back in here. Y will equal 2 minus 1. Oops. Okay? This is the substitution method. Have you seen this method before?
Yes.
Yeah. Of course, I will. Maybe not, of course. You wrote this down, Ming? Yeah. You all got this?
Yes.
Yeah? Yeah? Okay, next method. Elimination method. So let's say we have, I don't know, 3x minus 2y equals 10, 2x plus 5y equals 1, whatever. In this method, you try to make x or y the same by using a multiplication. So for example, here I could multiply this by 2 and I can multiply this by 3. Now I'll get 6x minus 4y equals 20. Yeah, and then 15y equals 3. Then what you do is you can add or subtract. What should I do here? Add or subtract? Subtract. 6x minus 6x is gone. Minus 4y minus 15y is minus 19y. 20 minus 3 is 17. So I have y equals minus 17 over 19. But how do I get the x? Sub it in. I think this one is a little easier. Well, no, it's about the same. So 2x minus 5 times 17 over 9 equals 1. So x will equal 1 plus 5 times 17 over 19 over 2. Yeah? Which is over 19 over 2. 95 and 19, isn't it? 95, 105, 100. Is it 114? Is it? Help a teacher out here. What's 1 plus 5 times that?
You can just move over 19 when you change x. When you make the x subject.
Why did I say 77? 57 over 19.
104.
This is 52 over 19.
No. 104.
Oh, 104 over 19. So this is 52 over 19. Yeah. Yeah. Okay, I believe you. Alright. What's wrong, Ming? No what? No problems? Yeah? If I, guys, if I have two lines, will they always meet?
No.
No. When do they not meet? Hmm. So how many answers do I have if they're parallel? 0, 0, or infinite. Depends. Let me show you. So there's two special cases. Take the case when you have whatever, x, well, I'll write it right there. Y equals x plus 2, and then the other one is, say, 2y equals 2x plus 4. Now they look like different equations, but they're the same, aren't they? So really all you have is this, y equals x plus 2 and y equals x plus 2. How many answers are there? Yeah, there are infinite answers. Because what you have is two lines that are actually the same. So how many times do they meet? Well, everywhere. So for example, you could have 0, 2 as an answer. You could have 1, 3 as an answer. You could have 2, 4 as an answer, etc. There are many numbers I could pick that will make this and itself true. So this is a special case. You know, this is the type of question that might be in the exam for 1 mark. At the end of a long question, they might say something like, you know, it might be, oh, show that line L and line K are the same. So you would just go divide by 2 and you see it's the same. And then maybe for the last 1 mark in 20 marks or whatever, they might say, therefore, how many solutions are there? Something like that. When do you have no solutions? Well, that would be something like this. Let me just make space here. So you've got two special cases. You've got infinite solutions and 0 solutions. And that might be something like this. Y equals 2x plus 3 and y equals 2x plus 4. There's infinite solutions there. The first line is like this. Passes here at 3. And the second one passes here at 4. They never meet because it's the same slope. So here there are 0 solutions and here there are infinite solutions. Okay? I think you should write both those examples down. They're good examples of two special cases. You wrote that down?
Yeah.
You know, even though I had burger and chips, I'm still hungry. Because the cycle was such hard work. Such hard work. At burger, chips and chocolate milk, I'm still hungry. It's terrible. I'm thinking what I'll have next. Maybe a donut. That
What's
sounds
the
good.
release tomorrow?
Huh? Pizza? Huh?
What's the release tomorrow?
Tomorrow? Don't know. Don't know. I'll see what I feel like tomorrow. Okay, have you got that? Not yet? Okay. I mean, today's Wednesday, isn't it? Yeah. Okay, you should have that now, yeah? Yeah. Now, there's one method left. The good news is, this method I'm about to show you is not on the exam. What I mean is, you can use this method, of course, but they'll never force you to use it. They'll never say, use this method for the next one. So like, the next method is called Gauss. Now you can use this Gaussian method if you want, but like I said, they will never make you use it, okay? It's optional. But it's a nice method, I like it. I'll show you how it works. So let's say well actually let's use the last one. Call out the last one I did. What was the last one? 2x. Yeah. Was that it? Guys, come on, just tell me, what was the last equation I gave you? The last question.
3x
Yeah.
minus 2y
Yeah?
equal
Equals what? 10. And then?
2x plus y equals 1.
Okay, let me show you the Gaussian method. So what you do is you create a block where you write all the numbers in the block. 3 minus 2, 10. 2, 5, 1. And this represents this. It's the same thing. Okay? And you have a couple of rules here. I'll give you the rules. These are called rows. Row 1, row 2. So you're allowed to multiply any row by any non-zero number. So you can multiply this by 2 or 4 or whatever. Okay? You're also allowed to add or subtract 2 rows, and then you can put the answer on either row. So for example, you could do row 1 minus row 2 and put the answer on row 2. Or you could do row 1 minus row 2 and put the answer on row 1. You could do row 1 multiplied by 10. You could do row 2 multiplied by 100. These are the 2 rules. You can multiply by any number that's not 0, and you can add or subtract any rows together, and you're allowed to put the answer on either row. Now, I'll explain with the example. We'll see. So what I need to try and do first is I need to try and make these the same. So my first step I'll do, step 1, is I'll do row 1 multiplied by 2, and row 2 multiplied by 3. And what do I get? I will get 6 minus 4 and 20, and then 6, 15, 5. Oh my goodness. 6, 15, 3. Yeah? Now, next, step 2. What I'll do is I'll do row 1 minus row 2, and I'll put the answer onto row 2. Okay? So I keep row 1 the same, but now I'm doing row 1, row 2, answer onto 2. 6 minus 6? 0. Minus 19, and then 17. Okay? Now, what I'll do next, I'll squish it over here. I'll do row 1 times 19 and row 2 times 4. So I'll need your help with the calculator, please. 6 times 19. 114. And then 4 times 76 minus 76. And then 304. 20 times 19.
380.
380, isn't it?
Yeah.
And then 0 minus 76, and then 17 times 4. Are these all right? Yeah, no mistakes? Yeah. Now, next, what I'll do is row 1 minus row 2, and I put the answer onto row 1 this time. Yeah. So I'm keeping row 2 the same. Okay. 114 minus 0?
Same.
Yeah, 114. Minus 76 minus 76? 0. And then 380 minus 68? 312. And then finally, last step, step 5. I'll do row 1 divided by, or if you prefer to think about it like this, multiplied by 1 over 114, and row 2 multiplied by 1 over minus 76. So I know I'll get 1001 here. Okay, 312 divided by 114, what's that, please? And then, where is it? 68 over minus 76.
It's negative 17 over 180.
Now look at what you have. Remember what this represents. How many x's do I have? 1. How many y's?
0.
So 1x plus 0y is also known as just x. 0 x's plus 1y, also known as y. And what did this line represent? Equals. So what am I saying here? I'm actually just saying x equals 52 over 19 and y equals minus 17 over 19.
You enjoy this?
Yep.
You enjoy
I sure
this
do.
method?
Yep. It's great. And remember I said it's optional.
It's not difficult, but if you need to study computer science about
Yep.
actual real,
Yep.
this will
Yep.
be very convenient. And because it's very convenient, it's hard to study. It's more difficult than...
Yeah. Well, the thing with this method is, okay, what's really great about this method is it works so well when you have more than just x and y. You know, like if you had 10, you know, A, B, C, D, you know, like if you had many variables, this method works quite well. And this is why you're saying it's good for a computer program, because you can have a program do all these steps. You can make an array and you can manipulate it, and you can have the program do it automatically.
Yeah.
You know, like for example,
And
why did I pick 2 and 3 here? Well, so I could make these both 6.
Yeah.
So a computer program could figure out
and
that.
it has a very low constants when it's run. And
Yeah.
it can deal with problem with it can improve about log n time to solve the problem. And it's very important. It's a very
Well, it
important
is very important if you had like a million
yeah.
variables, yeah.
It's a very
The thing
important-
Kei Hong is saying here is that this method doesn't use a lot of
not in
processing power on your computer. Even this computer could use this method. Yeah.
Yeah, it's a very important topic in the National Olympiad in China.
Oh, is it?
Yeah.
Ah, right, okay. A lot of you are doing computer science, aren't you? Yeah. Good. So you'll see this method again. I mean, in fact, this little method here is only one small part of a semester of work that's similar to this. This is what do you call this topic?
Abstract algebra.
What is it?
Abstract algebra.
It's
No,
not quite
no,
abstract
no.
algebra. Well, no, actually,
In China,
linear algebra.
in
Yeah.
in Chinese computer science, this part is independent part. We call it the mathematical part.
She's
I-
got a maths. Oh, that's
yeah,
not a good name.
I started to study this part from I was grade 2 in high school, and until now I can't write a correct Gauss eliminated code.
You can or can't?
Can't.
Okay, okay, all right. All right.
Because
Well,
I'm
well,
zero.
don't worry. If you do computer science next year, you'll have another chance to practice. Yeah, how many people here are computer science? 1, 2, 3. Oh, 1, 2, 3, 4, 5, 6. Oh, wow. Okay. So like half the class. Yeah, yeah. So this is good that you've seen this now. Is there? Yeah, there's not really time to do another example. So let me tell you which ones I want you to do, and you can get a start on it. Oh, so each with this last method, your goal, your objective in the last method is to make 1001
Yes, it's
as
a
the
unit-
final.
unit
Yeah.
matrix. Unit
Identity matrix, not unit matrix. Identity matrix. Yeah, 1001 is your goal here. John, but look. To be honest, if you want to forget about this one, that's fine, because like I said, in the exam, they'll never make you use this method. I wanted to show you this method because you're doing computer science, and you'll see this method next year and things like this. Okay. So what I want you to do for homework, and you can start now for 5 minutes. Questions? Homework. 1A. 2A. Yeah, 1A. What's wrong? Next page. Page 8. 2A. 3. No, not 2A, sorry. 2A and 2U. 3A and 3X. And the last one here is only for the students doing computer science. Yeah, I'm serious. 4A.
I'm engineering.
Yeah, but next year, what are you going to do?
I'm getting
Yeah.
computer science.
Yeah. 1A, 2A, 2U, 3A, 3X, and for computer science students, 4A.
I'm game developer.
Or game development, yeah, okay. Right, get a start on these now, please. Yeah, we've got 5 minutes. Come on, Marwan. Whatever you do now, you don't have to do at home.